Hi friends, welcome to this fifth video on Chebyshev's inequality. The problem for evaluation over here is, let x denote the sum of the numbers obtained when two dice are thrown. Obtain an upper bound for probability of x minus 7 greater than or equal to 4 and compare it with the exact probability. So we will be obtaining the upper bound using Chebyshev's, and we will be also evaluating the exact probability, and we will try to compare both the values. The action over here is throwing two dice. When we throw two dice, what we do is we consider x to be the sum of the numbers obtained. So if this denote the number on my first die and x2 denote the number on the second die, then my x is the sum of the numbers. So it is x1 plus x2. Now the number which happens to appear on the first die is in no way go to affect the number that rolls out on the second dice. In which case we can say that x1, x2 are independent of one another. Hence, we can just add them up to compute the data for the sum of the numbers, which is denoted by x. We will begin the problem by denoting x1 to denote the outcome of my first die, and let x2 denote the outcome of the second dice. So what is x? X is the sum on the two dice. Hence x is nothing but x1 plus x2. This is how we initiate the problem with. We will do all the actions for x1 that will be similar to your x2, and then the final answer can be added up to compute the results for x. When we have the Chebyshev's inequality, the basic requirements are my mean and standard deviation. So let me compute what is the mean of x1. How to get the mean of x1? It is nothing but summation x1 into probability of x1. What is x1? The outcome on the first die. So what are the values x1 takes? 1, 2, 3, 4, 5, 6. The numbers on a die. And what can we say about the probability of x1? Each of the numbers are equally likely to happen to roll on. Hence, their probabilities are 1 by 6 for each of these numbers. When it comes to mean, the value is nothing but x into p of x. 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6, 4 into 1 by 6, 5 into 1 by 6, and 6 into 1 by 6. Now this evaluates as 7 by 2. So E of x1 is 7 by 2. x2 is the rolling of second dice, and we know that E of x2 is also the same 7 by 2. So we block it as the first quantity. What happens? We make sure that this is going to be the quantity which is required. So E of x1 and E of x2 have been obtained. So now what happens to the next stage? I want my variance. What is going to be my variance? Variance is nothing but E of x1 square minus E of x the whole square. So moving on to compute the variance. For the variance of x1, I will be requiring E of x1 square minus E of x1 the whole square. How to obtain E of x1 square? It is nothing but summation x1 square into probability of x1. So it is 1 square into 1 by 6, 2 square into 1 by 6, 3 square into 1 by 6, 4 square into 1 by 6, 5 square into 1 by 6, plus 6 square into 1 by 6. So this evaluates as 91 by 6. Hence, I have my variance of x1 to be equal to 91 by 6 minus e of x1, which was 7 by 2, the whole square. So this gives me the answer as 35 by 12. Hence, variance of x1 is 35 by 12, which is the same as variance of my x2. Now, what we require is the mean of the sum of two numbers, that is mean of x. So, I need e of x. How to get e of x? It is e of x1 plus x2. I can split and write this as e of x1 plus e of x2. What was e of x1 obtained as? E of x1 was obtained as 7 by 2. So it is 7 by 2 plus 7 by 2. So the total value is going to be 7. So I have mu to be equal to 7. Now coming to variance of x. What is variance of x? So it is variance of x1 plus x2. We know the formula variance of ax is a square times variance of x. What is in place of a? In place of a, I have 1. So I write it as 1 square into variance of x1 plus 1 square into variance of x2. So it is 1 into, what was our variance of x1? It was 35 by 12. So 35 by 12 plus 35 by 12. Okay, so this makes it as 35 divided by 6. Hence, I have sigma square as 35 by 6. Now, my two requirements for Chebyshev's inequality has been got. We can now go to fix them in the required formula. Okay, so the question asks probability of x minus 7 greater than or equal to 4. So, what is my requirement? Probability of x minus 7 greater than or equal to 4. We have totally two formats for Chebyshev's inequality, out of which one suits better has to be now checked for. The first format has a greater than symbol over here, and the second format has a less than symbol over here. The question asks, what is the symbol in the question? Greater than. Where is the greater than? Here is our greater than. So what format we'll be using use? So we'll be making use of the first format. So by the first format, probability of x minus mu greater than or equal to k sigma will be less than or equal to 1 by k square. So probability of x minus, what was the value of our mu? It was 7. 7 greater than or equal to k times of sigma. What was the value for your sigma? Sigma was square root of 35 by square root of 6. So this is going to be square root of 35 by square root of 6 is going to be less than or equal to 1 by k square. Compare it with the given question. The given question is x minus 7 greater than or equal to 4. So now comparing will give us the answer for the value k. So from over here, what can we say about k? K times root 35 by root 6 is equal to 4. So what is k? K is 4 times root 6 by root 35. What is there on our right hand side? It is 1 by k square. So when I square my k, this k square gives 4 square, which is 16. Root 6 the whole square, so that makes it as 6. And this divided by root 35 will go to my numerator, and root 35 the whole square makes it as 35. So the answer for your Chebyshev now makes it as 35 by 16/6 are 96. Hence, probability of modulus of x minus 7 greater than or equal to 4 is less than or equal to 35 by 96 using my Chebyshevs. Now, The second part of the question demands us to find the value with the actual or the exact probability. So let us move on to the second part. So actuals of probability of x minus 7 greater than or equal to 4. So this is my requirement. What does our x stand for? X stands for sum of two dice. So where does my x begin taking the value? The first number which can roll out in my first die is going to be 1. The first number which can roll out over here is the minimum number is 1. So when we take the minimum of these two sums, the sum will be equal to 1 plus 1, 2. So when this keeps on moving as 1, 2, 3, 4, so on, my x takes 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and maximum value. The first dice can take is 6 and the second dice can take is 6. So the maximum value that can move on to become the sum of the two dice can be 12. Now I will have to find the corresponding probability of x. We will try to check out of these number which is going to actually satisfy the given criteria. Now let us take x to be equal to 2. 2 minus 7 modulus. This is going to give me modulus of minus 5. Modulus of minus 5 is 5. Is 5 greater than or equal to 4? Yes. So this now satisfies the given criteria. Next number to be taken is 3. 3 minus 7. So this modulus makes it as minus 4. Modulus of it gives me 4. Is 4 greater than or equal to 4? Yes, equality holds. So this is going to be true. The next number taken is going to be 4. What will be 4 minus 7? 4 minus 7 makes it as minus 3. Is 3 greater than or equal to 4? No. 3 is not greater than or equal to 4. Is 5 greater than or equal to 5 minus 7, which is going to be 2 greater than or equal to 4? No. Put 6, 6 minus 7 is 1, 1 is greater than or equal to 4? No. Put 7, 7 minus 7 is 0, greater than or equal to 4? No. Is 8 minus 7, 1 greater than or equal to 4? No. Is 9 minus 7, 2 greater than or equal to 4? No. Is 10 minus 7, 3 greater than or equal to 4? No. Is 11 minus 7. What is 11 minus 7? 11 minus 7 makes it as 4. Is 4 greater than or equal to 4? Yes, 4 is equal to 4. Move on to the last number 12. 12 minus 7. What is 12 minus 7? It is 5. Is 5 greater than or equal to 4? Yes. So, the possible number which can suit my x minus 7 greater than or equal to 4 are 2, 3, 11, 12. And now what is the probability of getting this 2? When I have 1 in my first die and 1 in the second die, I have the sum as 2. So the probability of x for this action is going to be 1 by 36. What are the chances of getting 3 when you have rolling 2 dice? I can have 1 in the first die and 2 in the second die, or I can have 2 in the first die and 1 in the second die. So the total chances for me are 2 by 36. Now coming to the number 11. How can I get the number 11? 5 in the first die, 6 in the second die, or 6 in the first die and 5 in the second die gives the sum as 11. So the number of possibilities for me is 2 by 36. And the chances for getting 12 is just 1, which is 6, 6. So the probability is 1 by 36. Hence, probability of modulus of x minus 7 greater than or equal to 4 will be equal to the case 1, 1 by 36, case 2, which is 2 by 36, case 3, which is 2 by 36, and case 4, which is 1 by 36. So, you finally have it as 6 by 36, which is going to be 1 by 6. So, through the actuals, the probability of x minus 7 greater than or equal to 4 obtained is 1 by 6. And through your Chebyshev's inequality, The value obtained is 35 by 96. When we are comparing, we see there is going to be a large difference between the value which we obtained through Tchebychev and which we obtained through the actuals. But Tchebychev gives us the range in which our answer actually falls into. Hence, it helps in estimating the bounds where our answer lies. Hence, the application of Tchebychev has been verified for the rolling of two dice. Thank you.